Hello, everyone. I have been working on adding value to these byproducts for several years now in the context of clay soil stabilization. So today, I like to present you this topic, interactions between clay soil and sugarcane molasses for use in construction. My research focuses on the physical, mechanical, chemical and geotechnical characterization and behavior of conventional and innovative geomaterials, ecomaterials, and semi-stable construction engineering. Sugarcane molasses is a produce of sugar production. It is used during the dry season to reduce dust, dirt roads in the industrial town of Nkayi in Congo, Brazzaville, development country. In this context of clay soil stabilization, PESACO demonstrates remarkable cohesive behavior on soil aggregates, fine particles. Shanibite, good compressive strength on workability of soil, concrete mixed with fly and hash pers. Malanda, me, and Nabel of over research mention the reduction of soil expansion in improved soil stability. Several research have worked in the direction of stabilizing fine clay soils. Study to date have focused on the effect of molasses of physical, mechanical, and geotechnical properties of soil. Over the internal mechanism responsible for soil stabilization using molasses have not yet been studied, including the problem of durability. So what contribution does molasses make to soil stabilization? What microscopic mechanisms have involved in the process of soil stabilization using molasses? That is the question. This operation works well in the dry season, but during the rainy season, the stabilized soil is washed away, will gradually crack until the stability equilibrium is broken, a durability problem. The first picture, molasses tipping operation. The second, pavement before application of molasses. The first, pavement after application of molasses period of dirt roads in the town of Nkayi to stabilize the soil in place. This is a map of Africa. This is a map of Congo and geographical local of town Nkayi. Alors, experimental design, method of determining the crystallinity of color. There are several approaches to determining this crystallinity. The first, clay index, P0 and P2 ration of infrared vibrational bands of kaolin hydroxyl, slope ration, and modeling nitrogen absorption. Define the quality of gas absorbed in a complete monolayer, then calculate the layer ring, the specific surface ring. Alors, result and discussion. Particle size distribution of clay station. The result of a number of geotechnical tests carried out on the soil I presented in table 1. The soil is a fine clay soil because it contains 88% fine particle and 54 clay. This is a value done. Composition of stabilized clay, concrete, quantity of sugarcane molasses to be introduced in the chair, percent composition, weight of dry soil, 88, weight of water, 54, 0%, 8%, 12%, 30, 50%. Coloring of clay coals stabilized with sugarcane molasses. Dry canes removed from the mold after in this picture. At the end of drying, the 0% clay cock has the yellow tint. Clay cocks contain 4%, 8%, 12%, and 15% sugarcane molasses are a greatest tint. X-ray infrared analysis, kaolinite crystallinity in soil stabilized with sugarcane. The crystallinity induced obtained from X-iridide diffractogram, infrared spectrum, P0 and P2, and thermal curves slope ration. Figure 3, and show in table 3. This is the value found. The value of crystallinity index P0 increased with the addition of molasses up to 12%. That decrease to 16% in the same order as the sample without molasses. The sample stabilization at 16 absorbed whether molasses molecule enter its specific surface that when the sample stabilized at 8% and 12%. The kaolinite study has a high density of surface defects at its slope ration in close to 2. Over the sample stabilized at 8% contain a higher density of surface defect than the all samples. Alors, ici the position. The sample with sugarcane molasses show the most intense peaks, followed by the sample stabilization at 16, then the sample stabilization at 12%, and finally the sample stabilized at 8%. The intensity of the peaks at these positions describes with the addition of cane molasses. This is interlattice distance of position. Comparison of parameters obtained use the BT model equation. The number of gas molecules absorbed on the monolayer also described with the addition of molasses. The sample with white molasses absorb more gas into the monolayer than the sample stabilized with molasses 8%, 12%, and 50%. This result suggests, just white please. This result suggests that the molasses-free sample is more porous than the stabilized samples, 8%, 12%, and 60%, and offers greater accessibility for the soil surface. Overall, this is 6% sample is more porous than the over 80%, 20%. The sample studies and 8% are more sugarcane molasses molecule absorbed well into the monolayer followed by the sample stabilized at 12. The 16% stabilized sample absorbed for molasses molecule and the monolayer, then for the other samples, 8% and 12%. The 8% molasses content appears to be the most optimal, as the number of sugarcane molasses molecule observed in height and porosity in layer. Analysis of the interaction mechanism between fine soil and sugarcane molasses. 1. Molasses dissolved in water penetrate to the surface of soil grains through the porosity. The molasses occupies the microporous and the mesopority spreading over the surface until they are fired. The industrial molasses iterated, the molasses spreads completely over the entire surface on the grain for the film of absorbed water. This is a grain lubrication. The lubricated grains interact with the molasses, adding cohesive force on the particular force ways of increasing between the grain of the molasses. Thus, physical interaction are established between the hydroxyl group of saccharose, glucose, and fructose, and the sinolol are aluminum groups of lateral and basal planes of clay. At the molasses content of 60%, the water content chickens of the water film, the effect of molasses lubrication, the grain weakened, and the molasses moves away from the surface of the grain, and the adhesion force between the closet of grains are weakened. We note all the force involved in this mechanism are physical. Conclusion, the addition of more molasses remarkably increases the compressive strength of the salt concrete. The maximum quantity of gas absorbed decreases with the addition of molasses 8% and 12%, then increases for the sample studies at 60%. The sample studies at 8 absorb more molasses molecule and to the monolayer than the sample stability at 12%. The candidate is our soil as for crystallinity. Sugarcane molasses help to improve the structural disorder in the candidate crystal at this at 2 counter of 12%. Interaction that take place of the outer surface of the community with the molasses molecule. In perspective, studying the durability of granulate soil concrete, carry out routine tests for control traffic problems in road construction. Thank you for your case.